So in our next section, 3.2, we're going to take a look at another derivative shortcut, and this shortcut is going to involve dividing two functions together, so we can appropriately refer to it as the quotient rule. So in the last section, we looked at the product rule when we're multiplying two things together. So for this one, we're going to look at the quotient rule where we are dividing two things together. And just as a review, we might not have to use the quotient rule every single time. Specifically, if we're dealing with polynomials, sometimes we can simplify those first and then simply use the power rule. So that's what we're going to try for the first one. So we're going to rewrite this function as a polynomial to help us first find the derivative. So if you take a look at the function, notice how we're dividing three items by one term. So we can individually divide each piece and simplify it to see what we're actually left with. So if we rewrite the function, 2x cubed divided by x squared would be a 2x, and then we have to subtract 3x squared divided by x squared, which would just be 3. And the next division wouldn't necessarily simplify to anything, but we can rewrite it. We don't have any x's that would cancel out, so we can simply move this x squared to the top with that 2 and make the power negative. So now that we have individual terms, no fractions, no parentheses, no roots left, we can go ahead and use our power rule. So that would be 2, the derivative of negative 3 would be 0, and the next term we'd have minus 4x to the negative third. Now we can rewrite this. Again, sometimes you should simplify, sometimes you might not have to. It all depends what the response might look like on the multiple choice type question. So I just want to get into some practice with rewriting these just in case you do have to. So for this particular term, if we have a negative power, we can move that to the bottom of a fraction. Okay, just in that individual piece, not the entire function itself. Okay, just this individual term has that negative power. And we could simplify it a little bit further. Notice how we're subtracting two things together, and one of those items is a fraction. So if we got a common denominator, multiplied the 2 by x to the third on top and bottom, we would end up with 2x cubed minus 4, and the common denominator would be x cubed. So all three of these are possible representations of what your derivative could look like. It all depends on which form the multiple choice question might be in. Sometimes they'll leave it with negative powers, which is okay, but we should be able to at least simplify it just in case we have to work with it for other types of problems. So being familiar with all three of these is definitely going to be a good thing. So this is going to lead us into what's called our quotient rule, and we can thank Mr. Newton for our quotient rule shortcut here. So we're going to say if we have a function h of x that's comprised of two functions being divided together, then we can write the derivative as such. So h prime would equal, this is going to be rather extensive, but just like the product rule, I'm going to give you a little phrase to help you remember this quotient rule by. So our quotient rule is the bottom function g of x times the derivative of the top function, so we can write that as f prime, minus the top function times the derivative of the bottom function. So right there, it kind of looks similar to a product rule, just instead of adding, we're subtracting. So there's a nice little pattern. And it's all over the bottom function squared. So again, rather extensive, but when we go through our little shortcut phrase, hopefully it will help you remember it. So my little phrase that students seem to like throughout the years is low d high minus high d low, square the bottom, and away we go. Alright, so I'll go ahead and say that again. Low d high minus high d low, square the bottom, and away we go. So we're going to take the low function times the derivative of the high minus the high times the derivative of the low, and we're going to square the original bottom. So if that helps you remember it, which it seems to do, at least for most people, I hope it works. So we're going to try to go ahead and use the same function as before, but this time we're going to apply our our quotient rule. We have so many shortcuts. We're going to apply the quotient rule shortcut to see if we can get the same result. So practicing our quotient rule phrase, we'll have the low function times the derivative of the high, so low d high, minus high times d low, so the derivative of the low would be 2x. We need to square the bottom, and away we go. So this is what the initial quotient rule would give us as a derivative. I'll probably tell you right now, this is not what it's going to look like on a multiple choice question, so we should be able to simplify this to something much more eye-appealing, if you will. So we can distribute some things to get rid of parentheses. We'll have 6x to the fourth minus 6x cubed. We can then distribute in a negative, but also a 2x into everything. So minus 4x to the fourth plus 6x cubed minus 4x. And that's all over x squared squared would be x to the fourth. So taking a look at this, we have 6 minus 4, so that would be 2x to the fourth. Minus 6x cubed plus 6x cubed, those are gone. And then minus 4x over x to the fourth. So this is much simpler, but again, we can keep simplifying. Notice how everything can be divided by an x up top. So if we take an x out of this one, it would become a 3. X out of this one, it would go away. And we divide an x from the bottom, that would become a 3. So 2x to the third minus 4 over x to the third. And notice how that matches what we had as our most simplified form from the top. So we can add this new derivative shortcut rule to kind of our list of shortcuts. We have the power rule, which was the first shortcut we discussed. We have the product rule, which was new to us in the last section, and now we have the quotient rule. And in addition to those, we have our two trig shortcuts, which would be the sine and cosine derivatives. All right, so we're just going to keep adding to the list as this unit keeps going on. All right, so let's see how we can relate this back to tangent lines and equations. We're going to find the equation of a tangent line to this graph when x equals -2. So this is when the quotient rule is very much needed because there's no way we can simplify this fraction since we're dividing by two terms. So we have no choice but to use the quotient rule for this particular example. Since we're going to write the equation of a tangent line, maybe we can find the point first. We can simply plug in -2 into our function and see what we get. So -4 minus 1 over -2 plus 3. We'll get -5 over 1, which is -5. All right, now for the slope, that comes from our derivative. So let's go ahead and apply our quotient rule. We need low times d high minus high d low all over the bottom squared. Notice how when I'm doing this, I'm putting everything in parentheses. It seems to be kind of a habit over the years that I've noticed students forget to put the parenthesis over this top function portion, and that parenthesis set is really necessary because you have to distribute in that minus sign. So please try to use parentheses when you're going through these shortcuts just so you can keep everything kind of nice and organized. Now let's see if we can clean this up. So we can distribute in the 2 and distribute in the negative. And it looks like 2x's cancel. So we're left with 7 over x plus 3 squared. All right, so there's our derivative. We want to figure out the slope at -2. So we'll plug in -2 for the x. And 7 over 1 squared, which would just be 7. So bringing our point and our slope together, we can write the equation of our tangent line. Y plus 5 equals 7 times x plus 2.